guys, my name is Craig and welcome to Peri Solutions. In today's video, we are going to talk about how we can use logarithms to reduce an equation to linear form. But before we start, please make sure that if you're new to my channel, hit the subscribe button and turn on the notification bell so that you don't miss out on any new video. So, first question is, why would we want to reduce an equation to linear form using logarithms? This is because for more scientific, economic, and social status quantities, right, they are drawn from either exponential graphs, exponential growth in decay graphs, or power, what is it called? Or yeah, those graphs, right? But now, thing is, we need to reduce the equations to linear form by taking logarithms so that some of the unknown constants, right, are measurable, and we can do this by, first of all, if you consider the exponential growth or decay, say we've got y is equal to ab raised to the power of t, where the variables are y and t, right? So if we take logarithms here, we've got log y is equal to log a plus t log b, right? So the graph of log y plotted against t, right, it has an intercept of log a and a gradient of log b. Then from the power law, y is equal to ax to the power of n, our variables being x and y. If we take logarithms here, we say that log y is equal to log a plus n log x, right? So the graph of log y plotted against log x is an intercept of log a and a gradient of n. So now I would like to attempt those questions that require us to introduce logs so that we reduce equations to their linear forms. So number one says, by taking logarithms, transform these relationships between the two stated variables into a linear relationship between two new variables and state the new variables. So for number 1a, we've got x and y that are related by y is equal to k x to the power of minus 2. So if we take logs, we're saying log y is equal to log of kx to the power of minus 2, which implies that log y is equal to log k, right, minus 2 log of x, right? So the new variables that we have, we've got log y and log x. Those are the new variables that we have. So log y and log x. These are the two new variables that we have. And log k is our intercept, whereas minus 2 is the gradient that we have. Right, then moving on to part B. Part B, we've got y and x that are related by y is equal to alpha root of x. So y being equal to alpha x to the power of half, and we take logs, right? We introduce logs both sides. Log y is equal to log alpha x to the power of half. We're saying that log y will be equal to log alpha plus 1 over 2 log of x, like this. So the two new variables, we've got log y and log x, right? And then log alpha is the intercept, whereas 1 over 2 is the gradient. And now moving on to part C. For part C, you've got p and t that are related by p is equal to 3b to the power of t. So introducing logs both sides, we're saying log of p is equal to log of 3b to the power of t, such that log of p is equal to log of 3 plus t log of p, right? So the new variables that we have here, we've got log p, right, log p and t, right? Those are the new variables that we have. And log b is the gradient, whereas log 3 is the intercept. So now we shall move on to look at number 2. Okay, so we shall move on to look at number 2. Number 2 says, for the following linear equations involving logarithms, find the relationship between the unknown variables in the form which does not involve logarithms. So in other words, it's simply working backwards, right? So for number 2a, we've got log to base 10 of y being equal to 1 is log to base 10 of 10, then plus log to base 10, 2 log to base 10 of x is the same as log to base 10 of x squared. Like this. So if we combine that, we've got log to base 10 of y being equal to log to base 10 of 10x squared. Then if we remove these logs to base 10, y is simply equal to 10x squared. So that's for the first part. Then for the second part, part B, we are saying we've got log to base 10 of v being equal to log to base 10 of 4 pi over 3, right, plus log to base 10 of r to the power of 3. So I've just raised this 3 such that it's r to the power of 3, right? Then we've got log to base 10 of v being equal to log to base 10, this is addition, so we shall multiply 4 pi over 3 times r to the power of 3, and if we remove these logs to base 10, v will be equal to 4 r cubed, let me write it as 4 pi r cubed over 3. So this is the result that we want for part B. Right. Then I'm moving on to part C. For part C, we've got log to base 10 of y being equal to 0.1 plus 1.3x. So if we, in this case, we could use this. We know that log to base b of y is equal to, say, x. This implies that y is equal to b to the power of x. So we can simply change this to index 4, such that we are saying that 10 to the power of 0.1 plus 1.3x is equal to y. Then this will be complete like that. Then moving on to number 3. Number 3 says the variables x and y satisfy the relation 7 to the power of x being equal to 4 to the power of 3x. Sorry, 7 to the power of y being equal to 4 to the power of 3x minus 2. So by taking logarithms, show that the graph of y against x is a straight line, right? And find the exact values of gradient and the intercept. So if we are to introduce logs both sides, we're saying that log of 7y is equal to log 4 to the power of 3x minus 2, right? And then if we drop this, this will be y log 7 is equal to 3x minus 2 log 4, right? And here, if we say y log 7 is equal to, if we expand, we've got 3x log 4 minus 2 log 4, right? Then if we divide both sides by 7, by log 7 actually, right? This will be by log 7, right? We'll get, and then this will cancel, so we'll get y is equal to 3 log 4 over log 7, right, times x, then minus 2 log 4 over log 7, like this. So, as we can see, this equation is in the form of y is equal to mx plus c, right? So this equation is definitely a straight line, right? So the graph of y against x would definitely be a straight line, because this is our gradient, this is our intercept. Now question says find exact values of the gradient. Gradient here, m, would be, here we can decide to raise the 3 to a power such that it's log 4 to the power 3, which is log 64 over log 0. Right? This is our gradient. In our intercept, c would be equal to minus, if we take this 2, if we raise it to a power, that will be log 4 to the power 2, which is minus log 16 over log 0. So this is the gradient, that's the intercept. Okay, so this was looking at how we reduce an equation to its linear form using logarithms. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.